Hello there, YouTubers. Today we're going to look at the following problem where we want to establish a domain of a function involving logs where, in particular, the base is a variable expression in terms of x, which I'm not sure how often you see these kinds of problems as a student, but there aren't that many in the textbooks that we typically have in college algebra or the high school algebra courses, so that is why I'm doing this as an illustration today. All right, let's go ahead and begin. And what we know is three things. So let's articulate those. One, we know that the argument of the log has to be positive. So we know 2x plus 1 has to be bigger, strictly positive, bigger than 0. 2, we know two things about the base. The base also has to be positive, so that would say 3x minus 1 has to be bigger than 0. But also, we've excluded the number 1 as a base for the exponential functions and also for the logarithmic functions. So the base can't be 1. The base, of course, I'm talking about this component of the function, has to be positive. And for this component, the argument of the log has to be positive. And of course, logically, these must all be mutually satisfied. So we have and conditions between each of these three. Does that make sense? So those should all be mutually satisfied. Okay. So let's see what that produces. So let's just work these out. And I'll do each one of these in turn. Okay, so let's see what we have. Obviously, if we solve this equation, this says that 2x has to be greater than minus 1, which tells us dividing by 2 or dividing both sides by 2. Now remember, 2 is positive, so you leave the inequality alone, so this will be the same inequality. So x is bigger than minus 1/2. Okay, for the next one, we're now going to look at this one. So this would say, last time we subtracted 1 from both sides, or now we're going to add 1. This would say 3x is greater than 1, and dividing by 3, again, 3 is positive, so we leave the inequality the same or leave it alone. X has to be bigger than 1/3. Now, finally, for this third piece, and this would say 3x can't be 1 plus 1, which is obviously 2, and then we divide both sides by 3. This says that x cannot be 2/3. So it's bigger than 1/3 from here, but we have to exclude 2/3. The algebraic form of these three, we need to find the intersection. So let's just graph them, simple way. And I'm going to put the same three numbers on all three graphs so we can form the intersection. Okay, so x being greater than minus 1/2, we'll say that we have an open circle there, and we're going to shade everything greater than 1/2. That'll be the solution to the first inequality, which you can see I'm kind of shading in here. Next, we know that x has to be greater than 1/3, so that'll give us a open circle there, and in shading, greater than means to the right of, so we're shading to the right there. And in our third statement, we have that x can't be 2/3, so we have we have an open circle at 2/3, and anything other than 2/3 is included in this one. So of course we have both sides. And what does that leave us? I'm labeling the graphs here for our convenience. Now again, we want the intersection. Remember, I had indicated that there's an and statement. You want this to be true, and this to be true, and this to be true, which says mathematically we're going to form the intersection. So what we want is the area that is common to all three regions, which you can see it here. It's anything not including 1/3, of course. To the right, anything out here, except we also have to not count 2/3. So I'll try to mark that here. We're looking at this So these three pieces, but of course, we have to not take 1/3. So the final answer here for the intersection, by the way, we could write this mathematically. Let's do it, it'll be a little more precise. This is -1/2 to infinity. This is the open interval 1/3 to infinity. This is -infinity to 2/3 union 2/3 to infinity. So mathematically what we have is the intersection. So the domain of the function would be the first interval intersected with the second interval, intersected with the third interval. But we need to be careful here. If you remember, intersection distributes over union and vice versa. So we have to make that computation. And I'm just changing the union signs there to black so they stand out. All right. That's it mathematically. Now, we already said we know what it's going to be. The open interval greater than 1/3, but not taking 2/3. So the intersection of all these three is as follows. It's everything larger than 1/3 up to 2/3, but not including 2/3, and then anything greater than 2/3. And so that's it. That's our domain of this function. It's the open interval 1/3 to 2/3 union 2/3 to infinity. And that's it. I hope that everyone enjoyed this problem. Kind of interesting where we have a variable expression serving in the base. And we'll see you next time.